morning, everyone. First of all, thanks for giving your morning and some of the time of your afternoon to us to sort of take you through uh, this particular workshop on MLOps, like building an MLOps platform with Kubeflow. So yeah, so just to start off and probably give you like a brief overview. We'll just start off with a short poll just to understand the pulse of the audience. So just to understand from the participants, like they can use the chat, but sort of answer the question: who has like deployed an ML model in production? You can use the chat, or probably you can unmute and sort of talk about it. That's great. Then definitely whoever hasn't deployed, then I think this workshop would really help them. The next question would be, who has used Kubernetes already? The last question would be, who is already using Kubeflow? Some of us have used it, some of us have not used it, or are not using it right now. Good, cool. Thanks everyone for the responses. So just to set up the agenda, like it's obviously a 3 hour workshop. I'll probably take a few minutes to talk about the boring stuff on the slides. I'll probably start off with the MLOps primer and just give a brief introduction to Kubeflow. Then Joinal will sort of take us through in-depth, details of the Kubeflow components, etc. And he'll also help us explain how do we set up the environment. And then Harish would sort of explain or walk us through how to build and run a pipeline. And in the end, if we have any questions, happy to take those. So quickly moving on to the MLOps primer, I think most of us already know this, but I'll just take a couple of seconds to talk about it. What is MLOps? Obviously, there are three aspects of building a ML-driven production system. You have data engineering, you have data science, and then you have software engineering. So at the center of this lies MLOps. It's basically it's a um, it's a amalgamation of processes and practices for sort of designing, building, supporting efficient development of ML models in production, so that we can continuously improve the business activity, which is the end goal for any specific ML driven system. So quickly moving on, this is just a typical machine learning life cycle. I'll just quickly go through this. You start off by defining your business case. You do a lot of data exploration. You sort of do run some experiments, select an algorithm. Once you're satisfied, you build a data pipeline. You do a bit of feature engineering. Then you build an ML model. Then obviously the evaluation is important. You then present the results to the business stakeholders, get their feedback. Post that feedback, you basically plan for deployment, and then you sort of operationalize your model. And then finally comes the model monitoring part, which is important, just to understand if the model is working fine and you're not experiencing any drift in the model. So it's an iterative approach, and yeah, it's not an easy approach. It requires a lot of effort and time, and a lot of hands-on from different teams. Um Quickly moving on to the next. This is, I think, again something that most of us are familiar from the famous paper on hidden technical depth in ML systems. So, doing enterprise machine learning it's a larger gamut. ML code, building an ML code or a script is just a small part of it. There are a lot more components that we have to take into consideration before we finally deploy a model into production. This is just highlighting the same thing in a different manner. So you start off with like we're trying to showcase an end-to-end ML journey here. You start off with your data sets. You probably have the feature store that you might use. Then you have Workbench, which is your Jupyter environment where you do your model experiments. Then obviously you track your experiments. Once you're finalized with a specific model, you sort of start training it. Once you train the model, you would want to deploy it on an endpoint, and then comes the pipelines and the monitoring part of it. So all of this, what exactly do data science or ML engineering teams ultimately want is they want a faster time to market. They want stability and reliability from their ML systems. Nothing should break in their entire pipelines. And then they obviously want more productivity. They want more reusable pipelines in future. Uh, this again is a typical MLOps architecture. I wouldn't go into the specifics of it, but just probably highlight the main parts of it. You have the model exploration at the deployment part, where you have everything from data validation to model training and model validation. As soon as you are sort of comfortable with the model, you sort of push it to your source repo, and then basically you sort of do CI/CD, which is continuous integration and continuous development. Once you deploy your pipeline, and then you also have the model update cycle, which is basically the continuous training part to your CI/CD. And then obviously, once you sort of update a model, you would want to push it to a model repo, and then finally use it for model serving. So this is basically a typical architecture. You can sort of think about it, whether your system is on any cloud provider, your ML model is a part of any cloud provider, or it's on-prem. Yeah. So that was a brief primer on MLOps. I'll quickly jump on to a brief introduction to Kubeflow. So before talking about Kubeflow, obviously the heart of Kubeflow is Kubernetes, and just to give a very brief overview, Kubernetes is an orchestration system for containers that is meant to sort of coordinate different clusters and computes of nodes at scale and in a production and an environment, which it does in an efficient manner. Now, now, Kubernetes is actually great for ML systems because obviously, as you can see on the slide, it provides you containerization, it provides you scaling, it provides you unified architecture. It's easy to integrate multiple building blocks, be it related to ML or be it related to data or any sort of other engineering aspects. And it has a lot of options for CI/CD, and the most important thing is it's highly portable, so you can do it in any sort of environment. You can do it on-prem, in cloud, and a mixture of both. So that is what that's why Kubernetes is great for ML. Yeah. So now comes Kubeflow. So Kubeflow is an open source Kubernetes native platform, which is primarily used for developing, orchestrating, deploying, and basically running scalable and portable ML workloads. So yeah, so it basically harnesses the power of Kubernetes and gives you the flexibility to sort of develop your own ML workloads that are highly scalable and efficient. This is basically overview of the different components that are part of Kubeflow. I wouldn't go into very specifics like details of this, but I can briefly highlight it has three major logical component grouping. One is your ML tools, which is any sort of machine learning framework that you can pick from open source and sort of use it with Kubeflow. And then the advantage of Kubeflow is basically it makes the Kubernetes clusters aware of the different execution nuances of each of these libraries, and It can sort of support parallel training or training on GPUs or TPUs, etc. With each of these machine learning frameworks. The second component grouping is basically your Kubeflow applications. So many of these components in this part are never used by the user directly, but they instead support a core functionality of Kubeflow. For example, Istio is basically for sort of providing the functionality of role-based access control and sort of distributed microservices architecture from Kubernetes. Um, uh, for example, Argo it provides continuous integration and deployment of functionality. And you have, for example, Prometheus, which provides you the monitoring capabilities of components, and basically you can even sort of query the monitoring data. So that's the middle section of the component grouping. And then last but not the least, you have your platforms or clouds. And it supports GCP, AWS, Azure on-prem, or you can sort of deploy it locally also. Installing Kubeflow on a public cloud, there are a few things that you should be mindful of. Obviously, understanding the cloud vendor integration with your own infrastructure, and you have to also make sure that the right version of Kubernetes it's supported for your organization. And then last and the most important thing is the security aspect of it, how it integrates with each of the cloud providers. What does Kubeflow offer? So basically, it gives you a lot of different components. To start off, like you have a user interface or a central dashboard to sort of manage and track your experiments, your jobs, your runs. It provides an engine for sort of scheduling different multi-step ML workflows. It provides you an SDK for defining different and sort of manipulating different pipelines and components. It also has component, or it also offers a component in terms of katib for hyperparameter tuning. Also for experimentations, it gives you the Jupyter Lab notebook interface, which you can use with the SDK. And last but not the least, it gives you the serving the model inference capabilities with kserve, so that you can deploy a model seamlessly and sort of monitor them on while they're in production. So at this point, I will hand it over to Joinal to sort of take through the next steps.
There's a question by Girish, in case you want to answer that, Nikhil.
So Vertex AI has something called as Vertex AI pipelines, and under which you can use both Kubeflow as well as TFX. Like you have the option to deploy both of them as a pipeline.
Yeah, just to answer the second part of the question, right? Vertex AI is not exactly Kubeflow, right? It uses a fork of Kubeflow, but there's additional like capabilities to which Kubeflow doesn't have. Okay. Thank you, Nikhil, for MLOps primer and introduction to Kubernetes and Kubeflow, right? So I'll just now do a little deep dive on the Kubeflow components and essentially what you'll be using today in the workshop, right? I'll not cover everything that you see in this slide, obviously, but we'll cover as much as we can that is relevant to the workshop today. Kubeflow pipelines, you can think of it as stepwise orchestrated, right? So if you have used tools like Airflow or any simple or DAGs, right? Directed cyclic graphs. These are essentially the same things, right? You break your overall life cycle of the whole ML model, right? As shown in this slide. Let's say you want to create a pipeline that orchestrates this whole architecture, right? So starts with you create one set of code snippet that does the data validation, then data preparation, then model training. Right? So you create these independent steps, and then you tie them everything together to create a now and pipeline that once it runs, the output of this pipeline would be a trained and a model, which is then stored to uh, a model repository. The second is, pipelines help you to now share and reuse these components, right? Now that you have created one component, you can share it internally with different members of your teams to rerun these experiments. And now, once you have this pipeline ready, you can, based on different schedules, you can run these pipelines every time, right? Based on schedules or in ad hoc manner, right? And this gives you the capability to do rapid experimentation, that you just change the data or maybe the hyperparameter that goes into training that model, and the same component pipeline runs every time you do that. Yeah, so like I said, so there are these, and every component, every step in this pipeline can be orchestrated via a Docker container. So you package your piece of code or your logic into a Docker container, and then provision it as a pipeline component. Now, every time this run, this is going to the Kubeflow master node is going to take that Docker container, orchestrate that job, and pass on the intermediate results across these pipeline steps. Then each and just a terminology, right? So each execution of this pipeline is a training job, and these pipelines you can provision via Python SDK. We'll have a look at that. So this is an example pipeline. Right? So if you see here the same model or same pipeline, we start with a pre-processing step, then go to feature transformation, and then this branches out to three steps, right? So now think of it is like this, right? Instead of you, maybe if you're doing in an traditional way of doing in Jupyter notebook, you'd only be able to run this job of like doing a TensorFlow training or a training a TensorFlow CNN model or an XGBoost, right? Here with this pipeline, you are actually orchestrating these all three jobs parallelly, and none of the jobs are dependent on each other, right? So after the feature transformation steps runs, these three separate jobs are created where you are training three models, and output of all of these are going to the model validation steps. Here you can compare maybe the model across these three frameworks, and then once you decide which is the best model, you can then decide to push it to serving and deploy it. Yeah. So the pipelines SDK, right, which is a Python library, this will help you to write all of these components, individual components, and also help you to write the logic of how these components are together, right, which essentially builds your pipeline, and help you to also so typically we data scientists work on Jupyter notebooks, right? So you can directly create this pipelines right from a notebook and push it to Kubernetes cluster on the Kubeflow, and this will be then created as a treated as a pipeline and can be orchestrated for any number of runs that you want to do going ahead. Yeah, so this slide looks a bit busy, but here essentially you can see how this is run, right? So essentially you create this is a descriptor, so you give this pipeline a name and a description what it does, and then it runs with you create a definition, right, which takes in your input output values, your all the metadata, and then you create all of the operations, right? So and these operations are like most of them are these components are available on Kubeflow, or you can also create your own components if you like, right? If you see a component that you need specifically for your workload is not available, then you can also write it and start using it. Yeah. So here, right? So the first is you create a Kubeflow container operation, and inside that you then pass on what is the container image, right? Which specific Docker container you want to use, what is the entry point, right? And what is the command, or what you actually want to run in that container, and where the output is going to be stored, right? So that then the Kubeflow master or orchestrator will run this and then look for the specific output in that location, and then pull it out and pass it out to the next step uh, as a part of the pipeline. Yeah. So Kubeflow is not just only Kubeflow pipelines, right? It has also a lot of additional components to it, right? So it starts with you can create essentially on your individual virtual machine where you run Jupyter Notebook, and on top of that you can do all of your experimentations, right? From data exploration, creating this much sample starter models, and then use the same notebook to now spin up large scale distributed training that trains your model, right? What TensorFlow also, what Kubeflow also has here is something called as an kfserve, and what it helps you to do is, it's a multi-framework model serving frame. So it helps you to now deploy any model without worrying about how or the steps to deployment, right? If you recall, every framework, right, be it Python, TensorFlow, scikit-learn, and everything, right? Everything has a different way of deploying models, right? And the steps to deployment for each models are different. But here with kfserve, you need not worry about these deployment steps for every. Yeah, so you need not worry about each of the steps. What you do is what you do is you just write essentially a YAML file. We'll give an example of that later. So you write a YAML file, and in that just give a location of where the models are, what kind of framework it is, and kfserve essentially takes care of to deploy that model, right? Kubeflow also has another component called katib, and what it does is to help you to now orchestrate these large-scale hyperparameter training jobs. You pass on the data, the model, and the hyperparameter search config, and then it will orchestrate all of these training jobs to now come to estimate the right hyperparameters that is to be used for that model. So under the hood, and this is an example. So this architecture, this is how it looks like. So user comes by an API, and then there is this API gateway, right, which is based on Ambassador. So now, based on the request you do, let's say you are requesting an Jupyter notebook, then it will go to that Jupyter Hub service, and then create a Jupyter notebook for you to start using it, right? Then for TensorFlow jobs, for any specific jobs, then you can, the TF master would not will now run these additional training jobs, and then give you the outputs. Ashish, yes, we are on the right slide. Yeah. So if you look at the overall big picture, right, and this is a typical flow, right? So it starts with the rollouts data, data that is on storage. So you then write these ETL jobs that dumps the data into some kind of a data warehouse. And now from Kubeflow, you can then start read these data from data warehouses or any other data sources, train your model. And then you have logging monitoring to now have a thorough control on your training workloads, your production workloads. And once you are satisfied with the model that you have trained so far, then you can go ahead and start serving them. Yeah. Let us look at the setup part of it, which is essentially the main agenda of the workshop.
I'll
Yeah.
stop.
Well,
Joinal, you can share your screen.
okay. I have shared my screen.
Can you reshare?
Yeah. Is it
I
visible now?
see I see a blank screen. Not sure if it's, yeah, now we are able to see.
Okay. Okay. Yes, right. So, do we, everyone has a Google Cloud account to start with this. Maybe just post on the chat if you have a GCP account to go through the workshop. Okay. In any case, right, I'll just quickly go over this installation step, and then we'll, assuming that everyone doesn't have a Google account, so maybe we'll look at the alternatives for that. Right? So to start with, you essentially do need a GCP account, and on top of that, you first create an auth client, authentication client to help you authenticate all the users that you'll be now onboarding into your Kubeflow deployment. Right? Uh, so, and the steps here are pretty straightforward. So start with creating this authentication client. So you give an auth name, the support email, and the domain names, right, where you want this service to be available. And once you do that, this is going to give you certain client ID and client secret. Right? This is what we'll be using later to now authenticate all the users that are there on the like maybe everyone in your data science team or all the users that you want to onboard into a cluster, right? The second part is now that we have an authentication sorted out. Second part is having a management cluster itself, right? So it starts with the architecture looks like something like this. So we have a management cluster on top, which is running your Kubernetes. And inside that, you are now running the Kubeflow pods. Essentially, these are pods running inside the Kubernetes cluster, which is helping to orchestrate all of everything that we have discussed so far. So deploying this management cluster is also very easy. What you can do is either you can go to Cloud Console and just create a cluster right from here. On a Google account, go to Kubernetes engine. On top of that, you can just click on create a container, and give all these details, right? That what kind of containers you want, in which region you want, the networking capabilities of it, what kind of IP ranges, what pod ranges can access these containers. Then things like automation and the service mesh, security features, right? Whether you want to allow role-based access control, or you want to encrypt all the secrets, and the metadata for that. Right? And once you click on review and create, this is going to create a container for you. Yeah. So once you and these are detailed steps for you to go through and run installation on this.
Joinal, can you zoom in a bit? Yeah,
Yes.
please.
Yeah. So starts with we download the Kubeflow deployment. Then the third is now that you have a Kubernetes cluster deployed for you. The next would be to now deploy Kubeflow on top of that, right? So we essentially do pretty much the same thing. We download the Kubeflow source code, and what you do is you uh, write this environment file. Here you have let me just show it to you. Yeah. So if you can see my screen here, what essentially, these are the parameters that you want to put in, right? Your GCP project where you want your this Kubeflow to be deployed, and same the Kubeflow, the GCP project number.
John,
The
we are still seeing the Kubeflow website screen.
Okay, let me just show to an entire screen. Yeah, is it visible now?
Yeah.
Okay. Yeah. So this is the environment file that you want to edit on your Qflow directory. So you start with giving the name of the Google Cloud account. Second is the account number, and this you can get directly just running this command, right? Google Cloud project describe the project name, right? And this will give you an output of this project number. You put it on here. Second is admin mail, so the master user of that Kubeflow deployment, and the management cluster name, right? So what is the name that you have given to the main Kubernetes cluster? So you put in the name here, and down here there are also some more parameters to be added. Right? So one is the Kubeflow deployment name. Then the cloud skill name, which is essentially your Kubeflow name hyphen Kubeflow. So the cloud SQL cluster, this is this Kubeflow deployment going to use. The cloud buckets, same. This will be created dynamically. One thing to remember is giving the right location where you want these deployments to be done, and the zone, right? Where exactly in the region, what zone you want your Kubeflow to be deployed. Once you do that, then you go ahead and remember the client ID and secret keys that we have generated earlier. So you create an environment variables that stores them, and you just apply your this environment file. What this script has is all of the steps to deploy your provision your Kubeflow deployment, all the pods, make sure that all the pods are communicating with each other, right? Your endpoints are available for you to now start using it. Uh, yeah. So I understand that everyone will might not have Google Cloud account, or everyone will not have this. So what we have also looked at is something called as a mini KF. Essentially, this is a very lightweight Kubeflow deployment that you can use to do an experimentation. Right? Remember that this is not a production grade, so you don't want to use mini KF for your production workloads, but for your experimentation, maybe you just want to deploy, run this on your local machine and just get acquainted with Kubeflow. This is a right place to start, right? Deploying this is also very easy. What you do is, you need be a machine like Vagrant or VirtualBox or something like that. And on top of that, then you can install Kubeflow. Or if you just don't want to go through all of these steps here to deployment, right? And you are just learning, what you can also do is go to GCP Marketplace and look for mini KF here. And this is the same minikf deployment that we have seen, right? So here the deployment is very easy. You don't need to go through all of these steps. What to click on is learn. And in here, you give it a name, the zone, and what kind of machine that you want to use, right? Do you want a general purpose machine, a compute optimized machine, with GPU, high memory, and so on, so right? you add the disk, right, the SSD where the boot disk and the data disk that is going to that this machine is going to use, and add network interfaces like what are the IP ranges this cluster can have access to, and other details. Right? Once you do add in all the details, we'll click on deploy. And what this will do for you is will create a deployment just like this. Yeah, just like this. And in this deployment, what you have is a cluster, a Kubernetes deployment ready for you, and you can directly assess it right from here to see if everything is running.
Joinal, can you zoom in?
Yeah. Yeah, is it visible now?
Yeah.
Yeah. So the first, and you just have to now do as instructed here, right? So this is asking you to type minikf to see if everything is running or not. So before that, what you want to do is just do a gcloud auth login. So what essentially you are doing is you're logging in with your Google Cloud account here, and then this will give all the necessary permissions to this machine to now execute everything on behalf of you, right? Since I've already done it, I'll not do the authentication again. Then what you want to do is since minikf, right? Yeah, if you see here, the cluster is created and it is ready for us to start using it, right? So we can go to this link here, and this now puts out the Kubeflow dashboard for us. This is a Traco distribution, and it's not entirely the native or vanilla Kubeflow, but it essentially serves the purpose of this workshop here. So you see all of these components here. To start with, there is this notebooks, and these notebooks machines you can use to now do all of your experiments. Okay. Yeah. So these notebooks you can start using to use to do all of your experimentation. Right? You can select new notebook, what give it a name. What you want to be installed in this machine. It's just Jupyter Lab, VS Studio, RStudio, or if you have any specific container that you want to run here, you can also select that. Right? Essentially, what you can also do is for your specific deployment for your team, you can create a Docker container that has Jupyter and all other frameworks that you need installed, and this is hosted in GCR. And you can directly use that container here to create new pods. Then give how much RAM and CPU that you want to assign to this machine. Essentially, if you want also to use GPUs and how many GPUs, what kind of GPUs you want to be used here. Volume, let's assume that there's a specific data volume that stores all your data, so you can directly link them here and then click on launch. Upon that, this will create this cluster with the config that you have given there, and this will create this Jupyter container notebook for you to start using. And the interface now here is very similar and is very relatable to all of us, right? So here you have ability to run the notebooks, or even command line prompts or Python files. The second is let's look at the experiments. So similar to right. So let's say you created an experiment there, and all of your experiments now will be logged here with all the metadata that you have created. Right. So now you can have a good understanding of what that experiment was, what it ran, what kind of metadata it generated, and then you can also have a look at each of the individual steps, right? For let's say this step, the run scalable transformer, this took these input files, then it generated this output where you see like things like the component ID, input artifacts, maybe visualization. Okay, details around it, the logs for that specific run, right? So if you want to go into detail and see what it actually ran, what kind of outputs it generated, and the ML metadata, right? For example, this was pipeline name was this, and this is complete, and this should be okay, estimator. Yeah. So now, so for example, on this run, you can also see the metadata that it generated, right? For each run, each kind of model, what is code that is generated, and then you can keep a track from all of this here. Yeah, I think that was at least on the overview side of the things. Maybe I'll give it over to Harish to now give a hands-on.
Joinal, there is a question on what will be running on the containers that you showed.
Okay, so in the containers, you can create this container based on how you want it. For example, let's say you typically work on a Jupyter notebook that you use a specific version of TensorFlow. So then you can install all of these packages on that container, and then use that container to now create these new notebooks. What it gives you that every time now you create a container with that you create a notebook with that container, you are sure that everything that you need to do your work is already installed, right? So every time you don't need to come here and do a pip install for all the packages that you will be using. And essentially this is the machine, this is the image that the machine will run, right? So everything that you have loaded into the container will be used here. Does that answer the question, Ashish? Okay.
Also,
So
anyone else has any questions? Please feel free to ask and interact. Okay, we can move on.
Okay, I'll pass it on to Harish to now give an hands-on feel on this.
All right, thanks, Joinal.
Hey, hi everyone.
Hi, everyone.
I will share my screen. I hope it is visible.
Yeah.
Can you see the screen? Yes. Okay.
Yeah, we can see.
So, yep. So this is what it is. Once we have set up a Kubeflow or a mini KF for this instance, what I am gonna do is we gonna set up a notebook wherein by we will visualize the data, take the data, and then train a machine learning model on that. And once we have that notebook, what we'll do is we will convert that notebook into a Kubeflow components and run that pipeline or the complete notebook via Kubeflow pipeline. Okay. So to start with, I will create a new notebook for everyone. Maybe lead demo. it will be a simple Jupyter lab which I'll be interacting with. This is a custom notebook wherein this particular base image will be taken. CPU, we can provide 4 CPU for this. That will be good enough. Volume, it's already being provided as 5 GB, so that will be sufficient. So if I click on launch, it will launch me a new notebook. Till the point new notebook launches, if anyone has any questions, they can ask. Also, with respect to any customizations on these notebook, what we can do is we can add data volumes, or even configure pipelines or already existing snapshots or Kubeflow pipelines. Okay. Also, if you have any custom container which you want to provide, you can also provide it in from here. As in, like, you have already developed some uh, containers or predefined packages which you want to use. So once I click into this connect, what I will land into is this Jupyter notebook, uh, which I am assuming everyone is familiar with. Okay, so now what I'll do is I'll launch a terminal over here, and we'll see it's empty as of now. So what we'll do is we'll clone the notebook which we are going to use.
Harish, there are 1 or 2 questions. Could you, I think it's important to understand before we move on.
Yeah, sure. Okay. Is Artica a free tool? How do we install this tool? So Joinal, you want to take this question? Hello, am I audible?
Harish, you are audible. Joinal, Harish is asking if you want to take that question. Is Arctic a free tool?
Yeah, it's a free tool. Meanwhile, I'll take the question. Yep, it's a free tool. It basically supports Kubeflow community, and yep.
And to answer Ashish's your question, yes, we're creating container, and that will create a notebook. So right now, what you see right now here, it's basically running inside a container.
Okay, we can move on.
Okay. So what I'll do is now is I'll clone the repo which we will be dealing with. So once I go into this, what we will be dealing with is this simple Titanic dataset, which we all, I am assuming, know. Okay. So over here, we can see that this is the notebook. So I will quickly run you down through the basic steps, or the end-to-end ML workflow. What basically we are doing over here. Initially, we are just importing the libraries which we want. Now we have provided the data path. What we see is we have 2 different CSVs which we'll be using. One is train set and one is test set. And we have around like 8 to 9 features, and around 891 data set, or around 1000 data points. Okay, so this is the train and test set which we will be dealing with. I will parallelly run on these cells. Okay, so it says to me that the modules are not installed. So what we can do is we can install the libraries. Meanwhile, I'll walk through the notebook. Okay, so once we import the libraries, we read the data, and then what we do is we play around with the data, which is like describe and head and all those things. Now, what we'll do is we will handle the missing data. Uh, uh, how essentially, like, what are the columns? These are the columns which have missing data points, which is cabin and age. I'll quickly walk through the features. What are the features? So basically, this Titanic ML dataset is survival prediction use case wherein we have to predict whether a passenger will survive or not, given these features, like what's the uh, class of ticket which they have taken, name, what's the age and sex. This is like how many siblings or spouse they have, or parents or children they have uh, within the ship. Okay, so yeah, based on these data sets, we'll predict this particular feature which is survived, whether they have survived or not. To deal with missing data, we will handle it later. Now, this is some EDA part which we have done. I will skip this because that's not very much required to develop the Kubeflow pipelines. So I'll share the Git link so that you can go through this. Uh, so once we are done with once we are done with once we are done with the EDA, what we'll do is we will handle the missing data. So or missing data. So yes. Okay, over here, what we are doing is we are converting the we are basically, if I run it, if I run the train df. Okay, I have not run. Let me see. The installations are done. Now I can run all the cells and notebooks. Yep. Now it's done. So exploring the data. Uh, skipping the EDA part. Now this is the data pre-processing part, where we are calculating relatives, as in since both of these columns represents siblings and parents, so we are counting in as how many relatives are there, and we will create a separate feature for that. And over here we are dropping the passenger ID, which is not required for training the model. Okay, so now what we are doing is for the cabin part, we have some numerics, or we have some text. We'll convert that into numeric, and this is the code base for that. And then we will drop the cabin, and we will have a new feature which is deck. Okay, and over here what we are doing is we are manipulating with the missing data of age, wherein we are filling in values between mean, standard deviation. Okay. Yes. Now we have embarked as well, where we have filled the embarked column with the most common value, which is S, and this is how we have imputed the missing values of the embarked column. Now uh, there is one more column which is fair, and now what we are doing over here is we are just filling the values with 0 for fair, for the values which we do not have. Again, some manipulation, where we are playing around with the titles of the name which is found on the name column, and we are again dropping the name, and finally using the title as one of the features. This is again some one hot encoding which we are doing, where in male and 0 we are mapping. Ticket feature, ticket is something which we are dropping, not using. uh, Again, some conversions, wherein we are converting the embarked into numeric. We are categorizing or bucketizing the age column over here. uh, Fair columns as well, we are bucketizing it based on some quantile values. So now we have age class as new features which we are defining. fare per person is one new feature which we are again defining. So this is the final train DF which we have right now. Okay. So what we have done is from the start initial data point, we have done some data pre-processing, done some feature engineering, created some new features, and this is the final DF which we will be dealing with. I hope everyone is aligned with this up till now, or if anyone has any questions. Okay, I'll take the silence as no. And so now what we do have is we have the initial training set of Titanic ML data set. Now we have pre-processed it, done some feature engineering, and now what we'll do is we'll train the model. Now, okay, so I will run the cells. Now what we have done is we have chosen 4 or 5 different models, which is a random forest logistic regression, Gaussian and innate bias, linear SVM, and decision tree. So basically, this is a classification problem. So this is why we have chosen these algorithms. So now in the result section, if we can see that we are plotting the accuracy score over here, which is
So,
coming
Harish, there
100
is a
over here,
question.
which I'll come to it later. Okay. So
Yeah,
now we have this particular notebook, end-to-end notebook, wherein what we are doing is we are loading the data set. Now we are pre-processing the data set, then training the ML model, and then finally showcasing the results. Okay. So now what we will do is we will convert this particular notebook into a Kubeflow pipeline. And for that, we will be using Kale. Okay, so Kale is Kubeflow automated pipelines engine. So what it is essentially it's an extension which can be used over here. We can see that Kale deployment panel, and once I enable this, okay, so once I enable this, what it will do is it will convert this whole notebook into components of Kubeflow. Okay, wherein we can define things. So it has what basically you have to do is you have to annotate each cell. By annotating each cell, I mean to say that like over here, once I click this enable thing, I will have this particular feature. What it will do is it will have different cell types. Okay, so these are the six types which by which we can annotate each of these cells. Okay, and what each of these cell will be a particular component of Kubeflow. I'll start with the imports, and maybe it will give more clarity. Okay, so this is a simple cell which is where we are importing things, so that's why we have defined this particular cell as import. So now this is done. This is the second part where we are loading the data. So what we can do is we can define this particular cell type as pipeline step, and we can name the step name as load data. So what I will also parallelly open one of the runs so that it will give more clarity. Okay, so yeah, this is the particular cell of this is a particular component of the Kubeflow pipeline which we are defining it over here. So this is a pipeline step which we can relate now, and the step name is load data. So that is how it is. So what it will do is this Kale extension, it will create a container out of this particular cell, and it will basically take all the basic configurations like the base image which will provide, and it will read the data. That's it. There are other add-ons which also we can add, like if we want GPU for this particular load data cell. So if we want to enable GPU for this, we can add, or we want to add some other configurations like metadata, environment, resources, we can also do it. Okay, so I hope I am clear up to this point. If anyone has any questions, they can ask.
There are some questions on the chat.
I have few questions. Okay, you are not splitting the train and test data. So I already have a splitted data set, which is train and test. So that's why I am not dealing with that. Kale will create containers for all the cells. Yes. So basically, Kale will create containers for the cells which we have defined as pipeline step. Okay. So you basically have to annotate each of the cell. So say suppose this is the cell which is traindf.info. I do not want to. I do not want to do anything for this particular step. So that is why there's one cell type which is skip cell as well. So we can skip that particular cell. Okay, so function is something where like if we want to enable some function, uh, like say suppose score model we have to calculate, or we just want to print something or define any functions, we can label annotate that particular cell as functions. Then there's like pipeline parameters. If we want to provide pipeline parameters like learning rate and learn or any model parameters, we can define that particular cell as pipeline parameters. Then there's like pipeline metrics as well, where we can export the metrics and see it in the uh, say over here. I do not see. Okay, this one. Just like this. If you want to log it, we can define it. Cool. So these are the components. So imports is something for which the Kale will not create a container. But for load data, since this is a pipeline step, it will create with a simple base image. Okay. Also, what we can do is, since this is load data is the initial step over here, this is just the resource setup. Now this load data is in the first step, so that's why we have not uh, put it as any depends on. Okay, so I will move ahead. uh, I am skipping all these cells because these are not required at all. uh, this is something missing data and data visualizations part or EDA part, that is not something which we want to include in the Kubeflow pipeline, right? So this is something which we do it as a part of our exploratory data analysis and to understand the data, and we do not need this kind of thing in the pipeline. So skipping all these part, now data pre-processing part. Once we have loaded the data, which is train df and test df, I am combining both of them and now playing around with that. So over here you can see that I have annotated this particular cell as data pre-processing. The name is data pre-processing and the cell type is as pipeline step. So again over here you can see this is the data pre-processing cell which we are doing. Okay, and now we can see that it depends on the load data part. So once the load data is done, then only this particular data pre-processing will start. Okay, and in this particular data pre-processing, what we can do is we can include all the things which all the cells which we have used to pre-process the data. So for this particular cell, we are using that. Now this is some visualizations which we can skip. Now again what we can do is if we skip the step name and define the cell type as pipeline step only, so what it will do is it will consider this particular cell in the previous pipeline step only, which is data pre-processing. So now data pre-processing will be this plus this until plus this or until I get uh, until I define a new pipeline step with a new name. Okay, so missing data, this is something. Oh, what happened? I just give me a moment. Not sure why it hanged, but let me see this particular cell is working. If yes, I will use this. Okay, so yeah, this is working. So this is same as the previous only. Yep. So I was up till here. Yes. So if I see this annotate, this will again be considered in the data pre-processing only. So up till this point, we are including all the steps in the data pre-processing part only. Like if you see, yep. Now the next part comes in the feature engineering. Now we have pre-processed the data. Uh, so what will happen now is this cell is done. Now we have moved into the feature engineering part. So for the feature engineering part, again collecting the data and creating new features. So now what we do is like we define the cell type as pipeline step. Step name is feature engineering, and now this depends on the data pre-processing part, which we can see it over here. Like once this is done, then only this feature engineering will get started. Uh, okay. So similarly, I will not go through each of them. We have annotated all these cells as pipeline step and not named anything, so that it will consider it into the feature engineering part only. Uh, so yeah, up to this point, also this point as well. This is all feature engineering which we are doing now. Now from this point, we are starting the machine learning model training. Okay, so I will again go through this. So once this is done, we will complete the first the data processing part as well as the feature engineering part. Now we have the final data which to train the model with. So what we have done is we will start the random forest model training over here, and again we have annotated as annotated this as a pipeline step. The name is random forest. Now this depends on the feature engineering. Okay, again we have defined few more steps, which is logistic regression, naive and all these models. But what you see is we can parallelly run all these models, right? So that is why, like, we for each of these cell types we have different step name, but all of these depends on feature engineering. So once the feature engineering block is done, this particular cell is done, or component of the kubeflow is done, uh, this all these five steps will start parallelly running. So yeah, this is how all the models will be trained similar to that, and then the final results. Now over here we can see that this is again a pipeline step, but this depends on five different things. And because since we want to collate all the results into one particular cell, that is why we have put this result block at the last. And once all the training is done, then what we'll do is we'll run this particular block of kubeflow. So yeah, this is how it is done. So as you can see, what we have done is we have taken up a simple machine learning end-to-end notebook, converted it into a kubeflow pipeline using Kale, which is a kubeflow automated pipeline development. Using Kale, we have like converted into kubeflow components. I hope up to this point everything is clear or defined to everyone. Any questions up till now? Okay, I will take the silence as no. So what we will do is once this is done, what we'll do is we will run this cell compile and run. So we have options over here: compile and upload, compile and save, and compile and run. So if you guys might be knowing, I'll first of all click like this, compile and run. So what it does is first validates the notebook. So this particular Kale has one another feature which is I think rock, which what it does is basically it takes snapshots of each of the components of the pipeline, so that at later point if we want to debug it, we can do it. Okay. So now it says uploading the pipeline, running the pipeline. We can, by clicking this, we can go to the pipeline directly, and we can see that yes, over here the pipeline has started. So this is volume creation and or the resource setup. Once that is done, it will go. So what essentially we are doing is we are using an extension which is scale. So now if I have to say, suppose convert this particular notebook into a Kubeflow pipeline uh, via SDKs, then I need to work with Kubeflow, like import Kubeflow components. Then there will be like DSL pipeline, container op. So for each of these blocks which I am showing over here, we have to define a container or provide an image, Docker image. What will be the parameters for that particular thing, for that particular block? So that is something which we have to do it manually or via code wise. But over here, Kale as an extension is providing us a shortcut or a fast tracked process which we can use. So if say suppose compile and save. Okay, if I run this compile and save, what it does is it will compile and save the YAML file. So essentially, if you want to run a Kubeflow pipeline, you need to have a YAML file which basically tells you each of the steps of the Kubeflow pipeline. So okay, so yes, this is the particular YAML file which defines each of the components of the Kubeflow. Okay, and that is how the pipeline is being run. So each of these blocks is defined over here somewhere. So like the first is create volume, and then there will be different all these different components which is defined in this YAML file. So the end goal is same. Either you use it via SDK or you use it via this extension. We will have this what I say, uh, this YAML file, and based on that YAML file, we will upload the run. So if you see, if I want to manually create a run, what I need to do is we need to define some configurations first, like which is the experiment name and all those things. And I am searching where we can basically put in that YAML file, and I think this is not the way. Just give me a moment. Okay, leave this. I will come back to this later. We'll go to the pipeline of ours. So you can see that load data is done now. So in the visualizations, we can see there are multiple things. So in the load data section, there might be no logs that is being printed over here. So that is why there's no visualization. But once the pipeline proceeds, we can see different logs over here. So for each component, you see we will have all the details like logs, what are the events, what's the ML metadata corresponding to that, like these are the steps, or yep. Any question up till now, like what we need to do or anything else?
There is one question actually by Girish.
Okay, if you want to have the pipeline, okay, so that is something different. This is staging prod. So this is for one particular run. Now you can have different naming conventions and different experiments. Like over here, we can see we have an experiments, right? So we can define different experiments which can be staging, prod, and we can play around with that. So for each staging or prod, the pipeline will remain same. The only thing that will change is the configuration or the heuristics which we follow, or the rules which we follow. Basically over here it can have like Titanic staging, prod, and all those things. So this will take some time, like it takes around 4 or 5 minutes to run. I will allow it to run. Meanwhile, if anyone has any questions, they can ask. So you see data pre-processing is also done. So yep, as you can see over here, we can see the logs as well. So whatever is printed over here, or that is what we can see directly over there as well. So we choose this particular Kubeflow once we have like when we are done with the research phase. So ideally we do EDAs and model training and all those things on Jupyter notebooks only, where we can play around with data or play around with different models. And then once we have like a sound approach, like now we have to try these many experiments or these many approaches, we have a fixed pipeline of EDA or fixed pipeline of feature engineering with little variation only and not much variation. Then only we start with the Kubeflow pipelines, where we can execute different pipelines parallelly and in a speedy way, rather than trying or benchmark for basically model benchmarking or model experimentation. If we say, suppose I want to run 15 different parallel experiments, right? So over there I can leverage Kubeflow and use the Kubeflow pipeline to run those experiments, rather than running 10 or 15 model experiments simultaneously, manually. Sorry. I think feature engineering takes the most of the time. So I will also talk about one of the features of Kale, which is basically which rock, which what it does is it takes snapshots of each of these blocks of the Kubeflow. So that is something which we can leverage if we want to debug something. Say suppose I got an error on this feature engineering block. Okay, now I want to rerun the pipeline. So if I want to rerun the pipeline, and this is, say suppose this is the last step, then ideally I will have to run it for all the steps again, and it will take that much time. Okay, so that is where which is one of the feature of this scale, is snapshotting, which is using ROK, which is rock. So for each of the Kubeflow component or cluster, it takes the snapshots, and we can directly come to this point, because basically we will skip all the steps that is before that, and we will directly come to this particular block where the error was, and we will rectify that error. And once we rectify that error, the pipeline will continue on. Okay, Nikhil, Joinal, if you guys want to add anything, you can. Oh, yep, the feature engineering step is done as well. So this is the final train df which we have printed. So that is what we can see it over here as well. Now the models training has started and as you can see, post the feature engineering step, we had all these 5 components of model training that is fine going on right now. So for each of these components, you can uh, define the number of CPUs you want or number of GPUs. So suppose I know that this is an image data set and the data pre-processing takes time, or feature engineering takes some time. I can assign a particular GPU for this particular block of pipeline. So essentially, each of these are containers only, which is connected via pipeline. That is what Kubeflow does. So we just have to define the image, the resource which we want to include for each of these cells. For the sake of simplicity, we have not deep dive into that, but yes, we can do that. Okay, now we see that all the model training is done. Now we'll go to the result section. So this should be finished soon. So this is what I was talking about, like snapshots, which it takes. So for each block, it takes a snapshot. So say suppose there is some error on this particular block. What I'll do is I will click on this restore workbench, and what it will do is it will uh, launch a new notebook with all the previous steps already done, and it will only start the notebook post this particular step. So I will go through it right now once the result is done. It is taking some time, but it will be done in some time only.
So Harish, can you meanwhile show if we can use a custom image on KF pipeline?
So meanwhile it is done, it has one more feature which I wanted to talk about, and that is models. So what we can do is we can deploy, as Joinal and Nikhil were also talking about it, we can deploy models over here as well. Uh, so basically, what you need to do is create a new model server, define some parts of that particular model, and what it will do is it will give you an endpoint. Uh, it will give you an endpoint which can be internal as well as external, and you can run predictions on this uh, by providing the input, whatever input this model requires, and you will get the desired output as well. Again, over here we can define whatever pre-built image which we want to have, a Docker container which we want to have, or whatever resource configuration which we want to have. Say suppose we want 16 vCPU or something like that, we can deal with this. Also, this have auto scalable facility as well. Like we can define the minimum and the maximum number of nodes which we want to have, and then that that will scale accordingly, since this is running on a Kubeflow Kubernetes cluster. Okay, so this is done. So now in the result section, we can see that the visualizations is done, and we see it's similar to what we are getting it over here, uh, which is a score of 100% for each of the cells. So what I have done is intentionally done is I have also included the label column which is survived in the train df. So that is why it is giving a score of 100 for each of the models. So say suppose now I want to rectify this error. So how I'll do is I will go to the random forest block or the first block uh, of the cell over here before any model training starts. And what I'll do is I'll go to the snapshots and I'll go to the restore workbench. Okay, so what it has done is it has launched me to a, a new UI where the rock URL is something which they have auto populated, which is basically the snapshot of that particular block from the start. Volume configurations is already predefined, which we have, which is similar to we have used. And once I click this launch, it will launch me a new notebook. I will give it a minute to launch it. Yep, it has launched. So now what we can see is just a moment. See, over here we can see initializing notebook for the pipeline step random forest. So it has initialized from this particular step only. Okay, so we can see so from the start of this particular cell, it has initialized. So say suppose if I print something. Okay, so at the start, right? So before this particular cell, whatever has run, it has initialized. So suppose if I run train df, I can directly see without running the previous cell. I can run train df. I can see what train df is. So now what I will do is I will remove. I'll fix this bug. Basically, I will remove that particular column. Okay. So how I can do is I will drop and use this column. Now what we have done is we have dropped the label column, and now what we can do is we can again enable kale a deployment panel on this particular notebook, and now this particular cell is already used in the feature engineering part, as we have defined this as a pipeline step, and this will be in the feature engineering part only. So now before the model training starts, we will drop the survive. Now I'll again hit this compile and run so that we can start the pipeline again. I will click this, and it has just started. So yes, the pipeline will again start. So a similar kind of pipeline like this will be created with the rectified or the bug being rectified. and we will see some different results over here. So ideally, this will again take around 4 to 5 minutes. So meanwhile, if anyone has any questions, they can ask, or like, yep.
Ashish, maybe you can unmute yourself and ask the question directly.
Thanks. So my only question was that for each cell a container is created and the step is performed within that pipeline. I was asking about what about the large data set? How we can uh, what you can say? How we can integrate means as per Nikhil, he was saying that we can use TF and
So
PyTorch for the
this
fast trainings.
whatever we have showcased it over here, this is
Mhm.
something from Aricto, and this is open source which we can directly leverage, or anyone can use or play around with. Okay, so if we want this to run on any enterprise-based solution, say suppose Google
Mhm.
Cloud, so Vertex AI is something which is similar to this only. We do not
Mhm.
have the KL extension over there, but we define pipelines via SDK, and there is a component of Vertex AI which is Vertex AI pipelines, and it is similar to this only, where we will have each of the pipelines, and we have to define each block of the pipeline, and yep, that's how we do it on Vertex AI as well. The approach is similar only. It's just the platform changes, and it gives you more flexibility and more options
So
uh,
I think let me
to
reiterate
define
my
your pipeline.
question.
That's it.
This is something which you told about the pipeline stuff. So as what I have learned, if for a large data set, we required a large compute, and for that large compute, so that it can, so that we can build our ML or AI model. So how that we
I
can
do
integrate with
not
our pipeline?
in the
That was the
how
question.
about the snippets?
So, if you have an existing pipeline, let's say it's
So
built on.
the pipeline, Anubhav, to answer your question, the pipeline runs from the start only, and we do not have this particular feature. So that is something which is available on Airflow or Cloud Composer, we can say. But for the Kubeflow pipelines, right now we do not have the capability to rerun the pipeline from that particular stage only. It will it will run from the start only. Uh, the second question is, in the rectification process, how about the snippets after the code? After the code, as in after the code, it will remain the same. Uh, so basically, the notebook only will get loaded before the rectification process. So since we changed the code, it was this one, sorry. So since we changed this particular code, so before this particular cell, all the cells will run, and we will have an initialized notebook. But post this cell, it will not. We will not have the cells which have already run.
Yeah, Ashish. So if you have an existing pipeline, let's say using scikit-learn the way Harish is using here, uh, I mean, obviously, if you want to
Can I
work,
ask my question again? Not clear. Okay. Yeah. Yeah. Sure.
yeah. So if you want to run it on a distributed framework, then obviously you'll have to build a TensorFlow or a PyTorch pipeline. Basically, build similar components the way Harish had showcased, the like data loading, pre-processing, feature engineering, training, and evaluation. And then basically you can run the same on your KF cluster, your Kubeflow clusters. Does that answer your question, Ashish?
Yeah, I think it's clear to him. He said, yeah. Anybody else wants to ask a question, feel free to unmute yourself and ask the question directly.
Okay, so one more thing which I was talking about was to create a pipeline via upload option. So this is what we had over here. This YAML file is something which is the final output. So anyhow, you create this YAML file to run the Kubeflow pipeline. Basically, you use scale extension, you use code, whatever you do. At the final, you will have this particular YAML file, and to run this YAML file, what you can do is we can directly upload a pipeline. Yes, Titanic YAML demo. Okay, pipeline created via. Okay, so now uploading a file. So what I'm doing is I have already downloaded this particular Titanic YAML file in my local, and I'm choosing that right now. So I have chosen that. So just by providing this YAML file, I can create a run as well. What is the error? Okay, already exists. Yep. So once I see the, you can see that this is what we already have created. So yep, this one. This should start soon. Okay, now I need to click create run. And once I start it, okay, I have to choose one experiment, basically use this experiment. And now once I start it, yep, over here you can see that this particular run is already creating. Meanwhile, I'll also see that okay, till the data processing part it is done, the rectified pipeline. Yeah, you can see over here via the YAML file also we can upload a YAML file and create a run as well. So ideally, this is how you have an end-to-end Kubeflow pipeline, wherein either you build a CI/CD pipeline and you push this particular YAML file to the Kubeflow, and once you push it, the new pipeline will start getting executed. So say suppose we have deployed our model uh, in the model section. Okay, so in the model section, say suppose this particular model is deployed, and we are also monitoring the model. Say suppose we saw a data drift now, or some model accuracy being dropped now. So what we need to do is we need to train our model again. So for that we might require some new data set. Say we have those particular data set in a SQL database. Now what we'll do is we will write the Kubeflow pipeline already, which will basically fetch that particular new data from the database and rerun the Kubeflow pipeline using this same components, and that is what it will. Okay, this is fail, but I'll talk that first. So it will run the same components again and it will retrain the model. So what is the error? Okay, no such file or directory. I'm not sure why it has not worked. Ideally, it should have. Okay, it has max.
There's some file missing maybe.
So we see that few only the random forest has failed. Rest all it has a run. It is most probably it is because of the resource is getting exhausted for this particular pool or the namespace which we are using. Uh, but I'll ignore this error since the rest of the models are done. So I will showcase the results via this notebook only. Say now we will train the model and see the results directly over here. So now we can see that it's not 100% for each of them, and it's random forest and decision tree giving us the best results of 93.04. Rest all have scores somewhat on the range of 80s. So yep, this is it from my side. I'll summarize it. What we have done is we had an end-to-end machine learning notebook, uh, wherein we fetch the data, pre-processed, feature engineering, then model training, and then finally the results. We converted that particular notebook into a Kubeflow pipeline. Then we ran that Kubeflow pipeline. Uh, then what we did was we saw that was one error. We rectified that particular error and reran that reran that Kubeflow pipeline, and yep, that's it from my side. Yep.
Thank you, Harish. Ashish, if I,
Joinal, Nikhil, and
yeah.
you guys
Ashish,
can take
I
over.
think if I understood your
Or from the
question,
KZT team, you guys can take over.
uh, am I audible?
Yes, you are. Yes.
Okay, Ashish, if I got your question earlier correctly, so you were asking that let's say in some steps you want to that requires more compute, and how do you computer memory, how do you do that? Assign more compute. Is that what you were asking?
Yeah, so what I heard or what I've learned is that AI and ML model requires a large compute. That is why we are not using, we are not building Jupyter notebook, any notebook on our local. So we are using a cloud-based solution. So
Yes.
that is the only thing which I was asking. If the cells are creating the container within the pipeline.
Yeah.
So
Yeah.
my question was where that ML model has been provisioned, or what was the compute for that ML?
Okay.
How we integrate with that?
Okay, okay. There are two parts to answer your question. Right, first is the underlying baseline Kubernetes cluster itself, right, where the Kubeflow is running. So the best practice is that you create a large enough cluster. Let's say you estimate, okay, at an average every day I have, let's say, 4 data scientists and they need large machines, right? So maybe you create a cluster with which has maybe 16 CPU, like 32 GB RAM. That's for their daily work, right? And you also then provision that Kubernetes cluster to scale automatically, so that when you have these large nodes coming in, when you have in need of this large compute, the cluster will scale itself to accommodate those workloads, right? And that will then give you the capability to, when you request for this larger Jupyter notebooks, the cluster will be able to provision it because it can scale up, kind of provision new machines and then give those resources to you to work on, right? The second part is, let's say, in your pipeline itself, right? There are certain steps which doesn't require much compute. For example, the step that just imports or the step that just reads the data does not require much compute. but there's a step that trains the machine, that trains the model, right, which is very compute intensive. So what you can do is Kale doesn't has this capability, but if you look at the native Kubeflow pipelines itself, right? Let me know if you can see my screen. So you can ideally create this pipeline step, and here you can then assign the CPU, memory, and GPU for that step itself. Now, what will happen is for the other steps of the pipeline, the default values will be taken, but specific for this pipeline step, the memory and CPU that you have declared here, those will be taken. This can also be configured via YAML files. If you look at the pipeline documentation, you can get these things.
So take an example of the SageMaker for AWS. So we do get an option to create a pipeline within that SageMaker.
Yes, you can create pipelines in SageMaker. You can create pipelines in Vertex AI. You can create pipelines in the enterprise distribution of Kubeflow, right? Selden, Aricto, and I think Tectron.
And yeah, so let me come to my another question is that there was an option to provide build parameters within that pipeline. So that is a model parameter like weight and bias when I talk about model in AI. So we can provide that parameters before the pipeline, the weight and bias or something like that. So you
Sorry,
talked
so
about
here,
model parameter.
yes, if you can pass, all the parameters that is required for that model to run, right? So that you can add in there. So the container you create, that should have the capability to take in these parameters as maybe like environment values, right?
I think we are giving through the pipeline, so it will take that variable, correct?
Yeah. So there also, if you have assigned the variables, it will take in those.
Yeah. Got it.
So if you create it using the pipeline SDK, then you have to give it via the environment variables, or if you just create it directly from K, so whatever you have declared here, those will be taken.
Okay, got it. Thank you.
Any other questions? If not, what was the question, Varsha? In the distribution process, how about the snippets after that? Varsha, can you maybe just explain your question a bit, because I'm kind of not understanding what you are asking exactly.
Yeah, actually, I was just asking when an error code is being rectified, the snippets above the error is being imported directly to the new notebook, right? So, to execute the snippets after that error, we have to start it new.
I again couldn't understand. So let's say there is an error in between a step,
Yeah,
and
so
you have rectified it. Now you can. So there are two ways now to start it. Either if you want, you can start the pipeline right from start.
okay.
And the second way would be to trigger that pipeline right from there. I'm kind of not sure if this Atrico distribution of this supports this, but the native Kubeflow and Vertex AI supports you to run that pipeline right from there.
Okay, yeah, fine. Thank you. Yeah, and then one more thing, can you just recall the setup process once again to just
Okay.
recall the steps?
Okay, so the setup is, this is a three-step setup, right? First is you want to create a cluster, Kubernetes cluster, and then on top of that, this depends on which distribution you are trying to install, right? If I go here, yeah. So which distribution you are essentially trying to install, it depends on that, right? So if you just want to deploy this uh, mini KF, so you just go on to my GCP marketplace. Let me know if you can see my screen. So if you just go to GCP marketplace, here select search for minikf, and you can directly install it from here on your GCP account. Second would be if you want to, let's say,
The screen is once again Joinal. The screen is stuck in the Kale deployment model itself.
Harish, if you're sharing your screen, maybe stop. Yeah. So the second is minikf, right? So one way is to deploy this via marketplace. So you just search for minikf in marketplace and click on launch, and then just give it a name, what kind of compute you want, and all these details, right? Second would be if you want to run it on a local machine, you can also do that using Minikube, right? So first you install Minikube, and on top of that you can then install Minikube. If you just go through, this doc, essentially what you do is you install any virtual machine client, either it is VirtualBox, Vagrant, or even Docker, right? And on top of that, then you can just pull in this container that has Minikube installed, and you are good to go to start using it. Okay, and the third would be to yeah. Yeah. So third would be to so there are these steps for each of the cloud providers, right? How do you install it on AWS, Azure, Google Cloud, IBM, or other services, right? So if you click on, if you just want to see for GKE, then what essentially yeah. So what essentially do is you create a GCP project, auth client. These are very simple steps. Then you look on installing it, deploying a management cluster, right? So you download this Kubeflow distribution package, and inside that there'd be one environment.sh file where you need to just declare these three variables: your management project name, what name you want to give to your cluster, your project ID, and the location, that in which region you want this cluster to be deployed. And once you provision that, just apply this file and you run this script, right? What this script will do is then take this environment variable, create the cluster in a Google account, and make it available for the downstream to now for the Kubeflow deployment part. And there are these three commands, right? Create cluster. So once you create cluster, you want to create context on top of that, and then give your account the permission to now manage this cluster. Then once you have the cluster ready for you, what then you can do is again with the same package that you want Kubeflow folder, and inside that there will be this environment.sh file. What this file has is these details, right? Things like your GCP account name, your admin email, the management cluster name, things like region, your Kubeflow deployment name, and these things, right? So once you declare these, yeah, here's the location, region, zone, and these details, right? So once you provision this, you can go back to your cluster and just apply this script. This will then provision all of the components for you and make it available for you to now use your Kubeflow deployment, right? If you just want to look at what are the kind of what pods are installed there. Yeah, so if you see, all of these pods are created for you, right? Katib, ML pipeline, TensorBoard, and all of these steps. So you can start right from here. I think that was all. Thank you for everyone joining us today, and do reach out us on LinkedIn if you have any more follow-up questions.
Sorry to interrupt you, Zonal. So, sorry, I have a doubt. So I just wanted to clear it. So, as we have installed Kubeflow onto the Kubernetes cluster, so the each cell which is creating a container, it is creating a pod or a container. Hello.
Hello.
Yeah. Sorry to
So this
have a
will
question.
take the container to create a pod.
So basically, a pod is created for every cell.
Yes.
Okay. Thank you. Thank you. No worries. Thanks for the session, by the way. It was new for me.
So thank you everyone. Thank you for joining us, and do reach out us on LinkedIn if you have any follow-up questions.